You know, every single modern web app has to answer one simple question. Who are you? But answering that question when you've got thousands or even millions of users, well, that's surprisingly hard. Today, we're going to break down the really elegant solution that powers pretty much everything you use online, the JSON Web Token, or JWT. And we'll do it by following a developer on a journey through a very common web development nightmare.
So let's meet Kiko. She's a sharp engineering student, and she's ready to build her first real project. She lands on a weather app, something practical, something she can show off to her friends. But what she's about to find out is that this simple app has a hidden layer of complexity that's going to give her a real headache.
So she builds it, it's working great, she proudly shares the link, and almost immediately, the texts start rolling in. And they're not good. Everyone is hitting the same incredibly annoying problem, a problem that's actually baked into the very DNA of how the web works.
And that right there, that's the heart of Keiko's dilemma. It's a concept every single web developer has to wrestle with, the stateless nature of HTTP.
So what does stateless actually mean? Well, just think of it like this. The server has amnesia, total memory loss. Every single time you click a link or refresh a page or do anything, the server completely forgets who you are. For Kiko's friends, this meant they had to log in on every single page. As you can imagine, the app was basically unusable.
Now, Keiko's a smart developer, right? So she implements a pretty common fix for this. But then something unexpected happens. Her app gets popular, and the solution she put in place starts to crack, and then just completely shatters under the pressure.
Her first fix was a session store. It's a classic solution. Basically, when a user logs in, the server creates a little note for them, a session, and gives their browser a unique ID number to hold on to. That way, the server can remember them. And this worked perfectly, as long as she only had one server. But then, boom, her app goes viral on campus. To keep the whole thing from crashing, she has to add more servers to handle all the new users. And to manage the traffic between those servers, she adds a load balancer. Think of it like a digital traffic cop. And that's when the real trouble began. A user might log in and get their session created on server 1, but their very next click could get sent to server 2. And server 2 is like, who are you? I've never seen you before. And just like that, they're logged out.
So Keiko's next idea is to kind of fight against her own system. She tries something called sticky sessions. This is basically her telling that traffic cop, hey, listen, if you see a request from this user, you have to send them to the same server every single time, the one that actually remembers them. But this approach, it's just not good. It forces her servers to be stateful again, which means they're all holding on to individual user data, and that's super inefficient. It also means some servers might get totally overloaded while others are just sitting there doing nothing. I mean, it completely defeats the whole purpose of having a flexible, scalable system in the first place.
Okay, so on to attempt number 2. Keiko thinks, all right, what if I create one central database for all the sessions, a place that all of my servers can talk to? That way, the servers themselves don't have to remember anyone. They can just ask the central database.
This is a way better design, for sure, but it introduced a new and honestly a terrifying problem, a single point of failure. Because now, everything depends on that one central database. If that database goes down, even for a minute, the entire login system for her app completely collapses. Nobody can log in. Game over.
So now Keiko is frustrated, probably ready to pull her hair out, but she keeps digging. And that's when she finds it. The truly elegant, modern solution to her scaling nightmare, the JSON Web Token. And this, right here, is the fundamental shift in thinking. This is the big aha moment. With those old sessions, the server has to do all the work. It has to hold the state and remember you. With JWTs, that responsibility gets flipped. The client, your browser, holds on to the token, and the token itself becomes the state. All of a sudden, the server doesn't have to remember anything at all. It can be truly stateless. And this is a brilliant way to think about it. Logging in is like showing your ID at the front desk of a secure office building. They check you out, and they give you a temporary access badge. That badge is your JWT. From that point on, you don't have to keep pulling out your ID. You just tap your badge to get into the rooms you're allowed in. Simple.
Now, JWTs help us with 2 really important ideas. The first one is authentication. This is the simple part. It's just the process of proving you are who you say you are. This is showing your ID at the front desk to get into the building in the first place.
The second, and equally important idea, is authorization.
This is about what you're allowed to do now that you're inside. Okay, so you're in the building. But where can you go? Your access badge, the JWT, might say you can go to floors 1 and 2, but you definitely can't get into the secure server room on the 3rd floor. All of those permissions are built right into the token.
So how in the world can a simple string of text hold all of this information so securely? Well, to understand that, we need to pop the hood and take a look at the anatomy of the token itself.
Okay, so a JWT might just look like a random jumble of letters and numbers, but it's actually a very structured message. It has 3 distinct parts, and they're all separated by dots. First, you've got the header. This is just some metadata, like which fancy algorithm was used to sign it. Second, there's the payload. This is the juicy part. It contains the actual data, like the user's ID, their role, and, really importantly, an expiration time. And third, and this is the most critical piece of the puzzle, you have the signature. This is the cryptographic proof that the header and the payload haven't been messed with. It's created with a secret key that only the server knows.
So let's walk through the whole dance. Step 1. A user logs in with their username and password. Step 2. The server checks them out and, if they're legit, creates a brand new JWT with their info inside. Step 3. The server signs that token with its secret key and sends the whole thing back to the user's browser. Step 4. The browser stores this token and includes it with every single request it makes from now on. And finally, Step 5. The server gets a request, sees the token, checks the signature to make sure it's legit and hasn't been tampered with, and if everything checks out, it grants access. Done.
This all sounds fantastic, right? Maybe a little too good to be true. And that usually raises a big question. If this token is basically a key that holds all the power, what happens if somebody steals it?
And that is a completely valid concern. I mean, think about it. Since the server doesn't have to look anything up, a stolen token is like a stolen master key. What's to stop a bad actor from using it to just waltz in and pretend to be a real user? And here's the critical trade-off with JWTs. Unlike a server session that you can just delete instantly, a JWT is valid until it expires. You can't just reach out and turn it off. So JWT security isn't about invalidating a stolen token, it's all about limiting the potential damage. Rule number 1. Always use HTTPS. This encrypts the connection so no one can steal the token in transit. Rule 2. Set very short expiration times. I'm talking like 15 minutes. That way, a stolen key becomes a useless piece of junk really fast. And finally, rule number 3, only give the token the absolute minimum permissions it needs to do its job. That way, even if it is stolen, the thief can't do that much damage.
So for developers like Kiko, JWTs solve that fundamental problem of trust in a stateless distributed world. They are the absolute backbone of modern systems, especially things like microservices, where you have lots of little applications all needing to talk to each other securely. By shifting the state from the server to a secure token, JWTs unlock our ability to build bigger, better, more resilient applications. And it's a powerful reminder that sometimes the most elegant solution isn't about remembering more, it's about knowing how to securely forget.